A prompt is a text input that guides the behavior of a large language model to generate a text output. Prompt engineering is a process of designing effective prompts that elicit high quality and relevant output from large language models. Prompt engineering requires creativity, understanding of the LLM, and precision. And this diagram you can see on the screen here illustrates how a large language model processes a given prompt to accomplish multiple tasks based on a different prompt instructions. Now let's break it down step by step. Now, on the left side here, we have the input prompt. This is step 1. On the left side, we see an input message. I'm Typhoon and I want to report an accident, hoping it will not take long. Now, this text serves as the input prompt to the large language model. A prompt is essentially a request given to the model to generate an output based on specific instructions. And at the center of the diagram, we have step 2, which is the LLM and decoder. Now at the center of the diagram, we see a neural network representation labeled large language model with the term decoder above it. Now the LLM processes the input text using deep learning techniques to generate relevant responses, and decoder is responsible for interpreting and generating coherent outputs from the processed input. Now this step is crucial here because an LLM does not inherently understand language like humans do. Instead, it predicts the most likely response based on patterns learned from vast amounts of data. And at the step 3, we have the task-specific prompt instructions. On the right side, we see that LLM can execute multiple different tasks based on a specific prompt instructions. Now, this is where prompt engineering comes into play. Now, by crafting well-structured prompts, we can guide the model to perform specific tasks. The model is given 3 distinct prompt instructions, and each instruction leads to a different tasks. At top, we have the prompt instruction named extract the name of the person. In this here, we have the model output. Name is Typhoon, and here the LLM identifies Typhoon as the person mentioned in the input text. Now, this technique is commonly used in a named entity recognition, NER, where the model detects names of people, places, and organizations from a given text. And then we have the sentiment analysis. For the prompt instruction size, we are basically telling to analyze the sentiment of the conversation, and the model output is negative and highlighted in this blue. Now the LLM here determines the overall emotion conveyed in the input text. Now, since the message involves an accident report, the sentiment is classified as negative. Sentiment analysis is widely used in a customer service, social media monitoring, and market analysis. And at the bottom, we have the summarization. Prompt instruction is summarize the below text, basically. The model output is a customer calling to report an accident. Now, the LLM here condenses the original text into a concise summary while preserving the core meaning. Now, summarization is essential for applications such as document processing, chatbots, and automated report generation. And at the end, which is step 4, the final structured output. On the far right side of the diagram, we see final structured response that integrates all 3 outputs. Here we see a customer named Typhoon calling to report an accident with a negative sentiment. This structured response is a result of combining entity extraction at the top here in the prompt instructions, sentiment analysis, which is negative, and summarization, which is calling to report an accident. And here we are demonstrating how a well-crafted prompt can transform raw input into useful, structured insights. Now, key takeaways of this lecture is prompt engineering is essential. Like crafting the right prompt determines whether a large language model will generate useful, accurate, and contextually appropriate outputs. LLMs can perform multiple tasks with proper prompting. Now, by specifying different prompt instructions, the same LLM can handle various tasks like entity extractions, sentiment analysis, and summarization. And understanding LLM behavior helps improve applications, like knowing how LLMs process input and generate structured outputs is vital for developing AI-driven applications such as chatbots, customer support systems, and data analysis tools. Now, this diagram I have created for this lecture illustrates the power of the prompt engineering, and the ability to fine-tune a large language model's responses by providing well-structured instructions. By mastering these techniques, developers can significantly improve the accuracy, efficiency, and usability of LLM-powered applications. And as you might imagine, the prompt becomes one of the key elements for an LLM-powered application's success. As such, it is pivotal to invest time and resources in this step, following some best practices and principles that we are going to cover in the next lecture. I'm Tayfun, thank you for watching, and I'm meeting you in the next lecture.